Starting on page 8 in your book, we're going to look at the first of 4 transformations. We're going to start with dilations. The reason we're starting with dilations is because it's the easiest to do, or it's one of the easy ones, but also it's the one that's the most different from the other 3. The other 3 are semi-related. This one's kind of its own transformation, and while you can incorporate it with the other ones, it's usually not put in or grouped in with the other ones. So starting off with dilation, it pretty much means you're going to change the size but not the shape of the figure. It's the only one that will change the size. The other ones will just change the location on a graph. A dilation will actually change the size of it, and it is the only one that will do that. And what we do is we use a scale factor. So if you think back to when we were doing proportions and we were talking about it's enlarged or it's reduced, and talked about scale factor, that was really doing a dilation. So if it's a scale factor that's greater than 1, that means that an object will increase in size. And if it's a scale factor of less than 1, so we're talking about fractions, because it's ratios, you're not going to see it as a decimal. That means that an object will decrease in size. And a dilated image will always be similar to its original image. The other 3 transformations, it will be congruent because you are not changing the size. This is the only one that's going to be similar because you are changing the size. We're not changing the shape, so if it's a rectangle, it becomes a smaller rectangle or a bigger rectangle. We're just changing the size. We are not going to change the shape. At no point in a transformation will you change the shape. Going forward, if you would like, pause the video in a moment and try it to see if it helps. What's going to happen is you're going to see my graphs come up, and I'm going to already have things graphed for you. So you may have to enable the pause on the video just to kind of help you keep up. If graphing is something you are struggling with, lunch tutoring and after-school tutoring would be an excellent opportunity to get these things figured out prior to any quizzes or tests. So we're looking at the coordinates below, and we want to know if we can identify what scale factor is used. And we want to know if we graphed it, would it be larger or smaller? So let's start with example 1. We have points A and B. So what we want to know is, how do we get from 5 to 10, 3 to 6, 2 to 4, and 5 to 10? Because they should all be the same. Hopefully you notice that you're multiplying by 2. Therefore, the scale factor would be 2. Then to determine is it larger or smaller, the answer would be larger. And the reason is, it's greater than 1. If we take a look at example number 2, what we're being asked is, how are we getting from -2 to -1, 4 to 2, 2 to 1, and 8 to 4? We notice that we're dividing by 2. Now, scale factor has to be multiplication. So therefore, your scale factor would be multiplying by 1/2. And just to prove it as an example, let's go with the 4 and 2 one. 4 over 1 times 1/2 gives you 4 times 1 is 4, and 1 times 2 is 2, and 4 over 2 simplified is 2. So notice I ended up with 4, 2 for that. Same if you did any of the other points. Now we know that this is going to end up being smaller because it's less than 1. And when we say greater than or less than 1, you're looking at the scale factor. So just to review, scale factor must be multiplication. And if it's larger than 1, it's going to be, if the scale factor is larger than 1, then the figure is going to be larger. And if the scale factor is less than 1, it's going to be smaller. The reason it's not 1 is because if we're dealing in multiplication and we multiply by 1, you're going to get the same figure again. Going on to page 10, we're now going to actually form some dilations. This is when you're going to start hearing me say stop or pause and have you do stuff on your own, or you're going to notice that my things are just going to suddenly appear when I do this. So what we're going to do is we're going to graph the original points and the prime points. What the prime points mean is that these are going to be the second points. So, for example, the original points are going to be called the pre-image, whereas your second points, your prime points, are going to be called the image. And the reason for this is you're going to have two figures put on your graph at any given point. And for the prime points, we use an apostrophe to help us denote it. So that's what they mean by A and A prime, or B and B prime. And it says use a straight edge. Please use a straight edge. Find something that's straight so that when you trace it, it all works out. If you try to wing it, it's not going to work really well. So it says use a straight edge after you graph them, and then have your line go all the way across your graph, and what do you notice about them going, and if they go through the origin. So I went ahead and labeled my graph, and I skip counted by 2s just because I wanted it spread out so that it was easily read. Go ahead and graph A and B. So there are points A and B. A, I went over 5 and then up to the 3. For B, I went over 2 and up to the 5. Now we're going to graph the A prime and the B prime points. Again, pause your video. So there's my graph with the A prime and B prime points. For A prime, I went out to the right 10 and then up to the 6, and that's A apostrophe, which is A prime. And for B prime, I went over 4, up 10, and put B with the apostrophe to indicate B prime. Now we are asked to draw straight lines that goes through the points, A and A prime, and they want it to go all the way across your graph. So please use a straight edge and draw your lines across your graph. So yours should look like this. Now my lines, I wasn't able to get them straight using a straight edge on the tablet, so I had to wing it, so that's why mine look a little funny. But yeah, so there is A and A prime, B and B prime with lines drawn through. And do the lines go through the origin? They do go through the origin. Now, we are asked to do the same for example 2, using the points for X and Y. Now, in this one, we are going to have to create our own coordinate plane because we're needing the top 2 quadrants because of the negative X coordinates. So when we draw it, the easiest way is going to be to split down the middle approximately. So that way we have the 2 quadrants that we need. So I've labeled mine. Again, hopefully you can see that I've skip counted on each of these just because I don't want my graph to be super squished. Now in looking at it, X is at -2, 4, and Y is at 2, 8. So I plotted the point X at -2, 4. I went to the left 2 and up 4. And for Y, I went to the right 2 and up 8. Now we're going to do X prime at -1, 2 and Y prime at -1, 4. Or excuse me, Y prime is at 1, 4. And there are the points for X prime and Y prime. For X prime, we went -1 to the left and up 2 to the and up 2. For Y prime, we went 1 to the right and we went 4 up. Now we are asked to do the same thing with the lines, meaning going through trying to get the 2 points connected and seeing do they go through the origin. Now, once again, I had to freehand my lines because my lines don't work with straight edges on this tablet. So when I connected the 2 points, we noticed that X and X prime and Y and Y prime, in both cases, they happen to go through the origin. Now, in looking at this, notice that for example 1, the prime points are further out from the origin, whereas on example 2, the prime points are closer to the origin. This is an example of this is an example of how a scale factor can be larger than 1 or smaller than 1. So once again, the line went through the origin. Moving on to page 11, we're asked to plot the following points for a triangle, and then we're asked to actually draw the triangle. So notice that it wants you to plot the points first because that's going to make it evident whether or not it's going to make the shape. Sometimes they list the points not in the best order. So plot the points first and then make the shape. That's kind of going to be the theme going forward. And then we want to apply a scale factor of 3. The scale factor of 3 tells us it's more than 1. And so if it's larger than 1, we know that the second figure is going to be a bigger one. We're then asked to write the new prime points and then plot them on the graph. So the first thing we're going to do is make our graph. Now, when we look at our points, we notice, hey, they're all positive. That means that we can stay in quadrant 1, so we really don't need to have to draw a coordinate plane on this. So I went ahead and counted, and once again, I skipped counted by 2s just because I want to make life easier. Now I'm going to plot and label my points for R, S, and T. So there are the points R, S, and T. For R, I went over 1 and up 1. For S, I went over 1 and up 4. And for T, I went over 4 and up 1. I plotted the points, I labeled them R, S, and T, and then I connected them. Now, we are asked to apply a scale factor of 3. This means our figure is going to get 3 times bigger. So what we want to do is, if we're looking at this mathematically, we want to take each of the numbers and we're going to multiply each of them by 3. So 1 times 3 is 3, and 1 times 3 is 3. 1 times 3 is 3, and 4 times 3 is 12. 4 times 3 is 12, and 1 times 3 is 3. Now that we have these coordinates, we come over to our graph, and we're going to plot them. And there are R prime, S prime, and T prime. Notice that the triangle did get bigger, and I did it in red. Hopefully you can see it okay, or at least it shows it better on yours. And that you'll notice that, hey, it did get quite a bit bigger, so it makes sense that it would work. We then have 2 questions at the bottom of our page that says, the first one says, what happens if you go to the graph figures and draw lines extended from each of the given points in its prime? Meaning, if we connected R and R prime, or S and S prime, and T prime, what would happen? They would go through the origin. And then how could you tell if the graph triangle would get larger or smaller? We know that it would get the scale factor. The fact that it was more than 1 means it's going to be larger. So now let's go on to page 12. We're almost there. Example number 4. We are asked to plot the following points for a triangle and then draw the triangle. Once again, notice it says make the points and then connect them. And this time we want to apply a scale factor of 1/3. This is a number that's less than 1 or that's smaller than 1. Therefore, that's a good indicator of what's going to happen to our figure. We then write the new prime points below and plot them on the graph. So when we did our graph based on the coordinates, I did mine a little bit differently, and it looks a little funny, but it's because this is the only quadrant we need. We don't need the 2 positive ones. We need nothing with positive. We just need the one that's going to be negative, negative. So I went ahead and skip counted again, just because I want everything to be spread out and easier to see, but also that I know it looks a little weird this way, but if you can envision, there's 2 quadrants above and 1 to the right. So now we're going to plot points M, N, and Q. And there are points in our coordinates. Again, the expectation is that y'all are going to use straight edges. Remember, you can ask me to borrow a ruler in class. I just want the figures to be straight. I'm having troubles getting it to work on the iPad, so please forgive the fact that my lines are not straight. But there are M, N, and Q, all plotted on our graph. So now let's come over to our coordinates, and we're going to apply that scale factor of 1/3. Remembering that scale factor means we have to multiply. So we have to multiply this by 1/3. We have to multiply each of them by 1/3. So if we have -3 over 1 times 1 over 3, -3 times 1 is going to be a -3 because 3 times 1 is 3 and our signs are different, so our answer is negative. And 1 times 3 is 3. When we simplify it, we get -1. This tells us that m prime is going to be -1, 1. And we also know that the y-coordinate for q will be -1. We come down to the second line, n for n prime. We know 0 times 1/3. It's going to be 0. That's not going to change. But now we have to do -9 over 1 times 1/3, which gives us -9 times 1 is going to be -9 thirds, which is -3. This tells us that n prime is at 0, -3, and q prime is at -3, -1. Now we can take this information over to our graph and we can plot it. And there's our figure. Again, we knew going into it that it was going to get significantly smaller because we're multiplying by a scale factor of less than 1, so it's a third as big, or it's getting 3 times smaller. And when we look, we say, yeah, look, the second one, I know it might be a little difficult to see, but the second one is smaller. Now let's come to the bottom and answer the 2 questions that we've been given. The first says, if we were to go to the figures and draw lines from each of the given points and its prime, what's going to happen? Well, so if we connected m and m prime and extended it, and q prime and extended it, and n prime and extended it, you would note that it goes through the origin. And how could you tell if it's going to get larger or smaller? Well, scale factor less than 1 means smaller. Now for the last piece on dilations. The other 2 were pretty straightforward, but what happens if the scale factor is negative? So we've seen what happens if it's larger than 1. We've seen what happens if it's smaller than 1. Well, let's go a totally different direction and really see if it's smaller than 1, and let's go with -2. So go ahead, make your conjecture, it's like your hypothesis, for what you think is going to happen if the scale factor is negative. Pause the video to make that conjecture. Now, hopefully you've paused it, and let's actually go through this process with a scale factor of -2. In this case, we are going to need all 4 quadrants, so when we draw our diagram, we're going to need to make sure that we have all 4 quadrants. So here's what my coordinate plane looks like. Notice that I've gone from 7 at the top of the y-axis, and it has to go all the way down to at least -12, and then same for the x-axis, I drew it from -10 to +10. So I'm essentially just skewed the axis a little bit just to ensure that everything is going to end up fitting. So now we're going to go through and we're going to plot the points for points D, A, and B, and then we'll deal with applying the scale factor and the prime points. There is triangle DAB plotted. I can make it bigger if need be. Again, this triangle is going to look a little bit smaller, and these figures are going to look slightly different just because I wasn't able to skip count due to the restrictions of the graph. So moving forward, we now look at our coordinates for DAB, and we're asked to use a scale factor of 2, meaning we're going to multiply every point, a scale factor of -2. So we multiply every coordinate by -2. -2 times -2 is +4. The signs are the same, so your answer is positive, and 2 times 2 is 4. 1 times -2 is -2. Multiply 1 times 2 and you get 2, and the signs are different, your answer is negative. We're going to carry the integer rules out as we do the last 2 points. -5 times -2 is +10. 1 times -2 is -2. -2 times -2 is +4, and 6 times -2 is -12. Now that we have our coordinates, let's plot these on our graph. And by the magic of TV, there is our figure, our prime points plotted. Now again, please, hopefully you're using a straight edge to help you, because we know we're going to want straight lines. There it is in all its glory. And so we look at what happened between the image points, or between the pre-image and the image. The first question is, what happens with this figure if you graphed the lines and drew them from extended from the origin? Or drew them, what happens? You should still note they go through the origin. And if you're needing to see this, pause the video and line up your straight edge and see if you connected B with B prime, or A with A prime, or D with D prime. Do you go through the origin? And you should note it does. If you're needing to see it, my book has those lines drawn. Because I'm not using a straight edge on these ones, I'm not drawing the extended lines, but if you need to see my book with it, just ask me in class and I'll be glad to show you. The final one says, describe what happened to the figure. The figure changed and the figure changed quadrants, and it's now twice as big.